What's up guys, welcome to Slake Academy. I'm Pradeep. Today we are going to see the chapter Reflection of Light by Different Surfaces. So before going for this chapter, we'll just see a brief introduction where that will give you much more clarity as you go forward. So let's go for the chapter. So as I just said, we are into the chapter Reflection of Light. Okay, that is reflection of light by different surfaces. Okay, so let's see. So when we see about the glass, this glass is of two types. All right, this glass is made into mirror, all right, or it can be used as a transparent glass. Okay, so now what is this transparent glass? In the sense, if you ever go to shopping mall, if you're standing in front of the shopping mall like this, all right, if any of the things which were there inside, suppose there is a car inside the shopping mall, okay, so now if you're just seeing the car, you could see very clearly through this glass. Okay, you're seeing the car which is there inside the shopping mall, you are seeing very clearly through this glass. Okay, because this is a transparent glass, whatever you could see, that you could see very clearly through the glass. So this is a transparent glass. All right, so what is this mirror? Mirror, in the sense, everybody might have seen the mirror where it will be there in our houses also, right? So mirror, in the sense, a plain glass, same, this plain glass which is coated at one side, that means it was painted at one side. So one side it was painted with the silver color. All right, so again on the silver color, one more other coating is made, that is, you're painting with again with one more color. So it is painted again with any dark color. Let's say, as example, it was colored with green color as an example. Okay, so first it is coated with silver color, then it is again coated with green color. Okay, now you can see your own image in this mirror very clearly. All right, so this is mirror and transparent glass. I hope you understand. So now here we are seeing about mirrors. So already you understood what mirror is. So now we are trying to understand what are different types of mirrors. All right, so let's see this. So mirrors were of three different types. So we'll see what they are. One is plain mirror. Okay, then concave mirror, then convex mirror. So I'll clearly make you understand each and every mirror where you'll have complete clarity. So as I just said, the plain mirror, it is just coated with a silver painting, and on that again one more dark color is painted. As we have taken example, so first color is silver and next color it was coated with green. So now you can clearly see your own image over here. All right, so now what is concave mirror? So mirrors were three, right? So this is concave mirror, the second one. In the concave mirror, if you see, this is the mirror which is a curved mirror, where one side it is coated, the bulge side is coated. Again it is coated with which color? Same, silver color. On the silver color, again it is coated with one more dark color. We'll say this as green color, right? So if you're standing over here, you can see your own image very clearly. Let's say one more mirror, that is convex mirror. In this mirror, again this is also a curved mirror where this is coated inside. Okay, so again the first coated is silver, first coating is silver, again it is coated with one more dark color. Let's say an example as green. Okay, so now you're seeing from this side, you're just standing this side and you're seeing your own image this side. All right, so these are three different types of mirrors. So before understanding more better ways about these mirrors, I'll just give you a brief information about each. All right, so there is a particular law which states about this mirror and the light which acts between this mirror and light. There is a law which is saying angle of incidence is equal to angle of reflection. So I'll give you more clarity here. Suppose this is a plain mirror. Okay, so in your house there might be many lights. So if you observe, the light gives many beams of light, right? From one light you will be getting many beams of light rays. Okay, so we are just taking one beam of ray and we are just observing that particular beam of ray characteristics. All right, suppose if you observe, this is a plane mirror, a ray which is coming like this and it is touching here to the plane mirror and it is going away. So this light ray which is coming from the light source, whatever the light source is there, so if the ray is coming from this light source, because this light, so if the ray is coming from the source, this particular ray we will say that as incidented ray. So we'll say incident ray. So the ray which is touching the mirror and going away, so this particular ray we will say as reflected ray. Okay, so incidented ray we can simply notate it with I, and reflected ray we will just notate it with R. Okay, so one more thing we have to observe here. So we will just observe what is the angle between incident and reflected that we will be seeing with respect to normal. So we're just taking a perfect perpendicular line, that is, if this is a glass or a mirror and we're just taking a perpendicular. So perpendicular in the sense there is 90 degrees between this glass and the line, this line. So we're just taking a perpendicular line. So to this line, this angle is equal to this angle perfectly. For the reason we will say incident angle is equal to reflected angle. We can say nothing but the first angle is incident angle, second angle is reflected angle. I hope this is very clear. So this particular mirror which we observed is plane mirror. Okay, so let's see the next type of mirror. So that is concave mirror. So before going for concave mirror, I'll just give you a brief idea about its characteristics and the ray directions and all the notations which we will take. Suppose, let's say we'll just take the circle and we'll try to understand. Suppose this is a circle I'm taking. To this circle, definitely every circle will have center, right? So we'll notate the center with C. Okay, C means what? Center of circle. C is center of circle. Okay, so I'm just taking a line which is passing through the center of circle. Definitely that is what? Diameter. So the line which is passing through center of circle from one end to other end, so this full line, that is what? Diameter, which we can represent with D. So half of the circle will represent as what? It was radius, right? So R is nothing but radius. Again, actually half of this R, okay, half of this R is actually focus, which means, see, from one point, this end point of the circle to midpoint of this radius, that is one focus. Again, from this focus point to the center of curvature, there is one more focus. Got it? So anyhow, F is focus. Okay, so now we'll try to understand more better ways. In one diameter there is two radiuses. All right, so this is one radius and one more radius is here. So one diameter equal to two radius, which is R plus R, it is 2R. Okay, so now here we'll even observe what about the radius. See, one radius is having two focuses, right? So from here to here one focus and from here to here other focus. There are two focuses in one radius. So R is equal to 2F. So now we understood R value as 2F. So in diameter we have here R. So in the place of R we can submit 2F because R is nothing but 2F. So in the place of R I will just write it as 2F. So now one diameter equal to 4 focuses. Okay, I just showed you in mathematical form, but still by seeing the figure itself you can notate it. See, from here to here this is one focus, from here to here second focus. Again this side also, other part here is also one focus here, other focus here. So how many focus? 1, 2, 3, 4. 4 focuses were there. Very simple. So in one circle there is one diameter and there is a 4 focus and 2 radiuses. I hope this is very clear. So just now we have spoke only about the circle. So now let's see what we could understand more better ways. So what is this? A part of the circle. We can say a part of the circle is called as a curve. So which means a line which is passing through the center. See, even to draw this curve we require a center, right? So a line which is passing through the center, this particular line we will say principal axis. Okay, so here in this case the big line which is passing through the center we are saying it as a diameter, but here the line which is passing through the center, that we were saying as principal axis. So principal means which is a main axis, a main way. All right, so as the line which is passing through the center, where center is the main point in the circle, so that particular line will say principal axis. And this part, wherever this point to the circle, whatever this point is there, that particular point we will say that as pole. Okay, so this is pole. Okay, we'll also represent with P. Got it? So now to this one again we have even focus. Okay, even we have radius also. So we have center of curvature. So here actually this center is what? Center of circle. But here to the curve, this C is not center of circle, it is center of curvature. Got it? And what is F again? F is again same as focus, as like circle, and R is radius. The new thing which is added here is, one is P, pole, other one is what? Principal axis. This pole is nothing but this full part, whatever this curve is there, this full that comes under pole only. So now pole can be represented simply as P. Alright, so this is all about the curve and its rotations. Alright, so let's see. So there are three important things which we have to understand, where with the three forms the complete reflection or refraction will be understood. Okay, so let's see the first form. Suppose this is a concave mirror which is coated at one side. Okay, so now of course definitely that should have center of curvature and that should have a focus also. Okay, so now suppose you take a candle over here, which means the source of light. So it is taking candle as a source of light and the ray is passing through the candle like this. So when you observe, from the candle the ray is coming. So this is what? Incident ray. So this ray is coming and it is touching the mirror and that is passing through the focus. So the ray which is passing through the focus, that is nothing but reflected ray. The ray which is coming from the source of light, that is candle, that is incident ray. The ray which is passing to the focus, that is what? Reflected ray. So now the ray, when you observe here, this is going parallel. See, this is the principal axis and this ray is parallel, very parallel to this principal axis, and it is touching the mirror and that is passing through the focus. This is the first rule. Okay, the ray when it is passing parallel to the principal axis and it touches the mirror, and if that is going through the focus, that is the first rule. So let's see the second rule. The second rule is that it is very simple and very similar also to understand. Again, this is also having the center and this is also having focus. Suppose let's take a candle over here. Okay, and the ray, it is passing, so one beam of light ray that is passing through the focus and it is touching. So definitely the ray is coming from the light source. So this is incident light or the incident ray. It is touching, it is passing through the focus and it is touching the mirror, and now it is making a parallel line here. Parallel to what? Principal axis. As this is parallel, so now this is the second rule. So that is passing through the focus, touching the mirror, and that is making parallel to the principal axis. So this is the second rule. So let's see the third rule. So third rule is, suppose this is center of curvature. See, alright, and this is the candle light. If the ray is passing through the center of curvature, that is incidented, and that comes back through the same center of curvature. So the incident and the reflection, the incidence and the reflection is happening in the same path. So as it is happening, the incidence and reflection is happening in the same path. So this is the third rule. So these are the three different rules which you will observe in this reflection, where this complete chapter deals with only these things. If you could understand more clearly this, so nothing but you understood very clearly about this reflection. So let's go for and try to understand more about this reflection, and we'll try to see different characteristics of this particular light ray when it is placed at different places. So now let's see the concave mirror characteristics. So we're just taking a candle and we're just placing the candle in front of a concave mirror, and we are positioning the candle in different positions in front of concave mirror, and we're just trying to understand the characteristics, and we're just taking one beam of ray from the candle and we're just observing the characteristics of a concave mirror. Alright, so let's go forward. First thing is that, so as I just said, we are into concave mirror. Okay, so the different things which I'm saying is that now we'll just take the position of object, and also we'll be taking the ray diagram for clear understanding. So we'll also take image details. Okay, so now first I'm keeping the object at infinity, that is I am keeping the candle at infinity position. So let me take a concave mirror. So of course it is coated. So this is having a principal axis, and this is the center of curvature. It is also having what? Focus. So now the first ray which we are taking is that is coming from very long distance, we can say from infinity. So that is passing through the focus like this, touching the mirror, and that is going parallel to the principal axis. Right, this is the second rule. You might have already remember this. This is incident ray and this is reflected ray. So now one more ray which is passing parallel to the first ray, that is touching that is passing through the center of curvature and is going and it's touching the mirror again. So that is going back in the same direction because that is passing through the center of curvature. That is the third rule which we have already discussed. So now here if you observe, here is the image formed. Okay, so image which is formed, that is very small, but the ray which is coming from very long distance, which is the object size, if you take, that is very big, right, very big. So because that is coming from infinity, very long distance, see, that is coming from infinity. So we can say, so we'll just try to understand what are the different types of what are the different details here, the image details. The image which is formed is real because that is truly formed. It is a true image which formed in front of a mirror, so that is real. So now it is also inverted. See, this is inverted image. Actually the object is like this because the rays were coming like this, but the image which is formed is that is reverse the direction, reverse to that of object. So this is real image, and also it was inverted image, and also where it was formed at F it was forming. So it is forming at F, and also how it is forming, that is very small compared to the actual size. So for the reason we'll say that is diminished. Whenever we are trying to explain something which is smaller than the actual size, suppose if initially that is 5 centimeter, but if the same 5 centimeter if you are showing in the 2 centimeter form, so that is you are showing it is in a diminished form. Or if not, if this 5 centimeter if you want to show more bigger, that is you are showing the 5 centimeter in the form of 10 centimeter. So this is enlarged. So this is diminished, where you are showing smaller than the actual size, but if you are showing bigger than the actual size, so that is enlarged. So try to understand these things because we will again see these things in the next cases. Alright, so this is the first case. So at infinity. So let's see the second case. So we'll be taking between infinity and C, or same thing we can say beyond C. We'll just say that as between infinity and C, or same thing we can also say as beyond C. And now we'll try to understand these characteristics also very clearly. So now I'll be taking a ray diagram. So this is a concave mirror, this is coated again, and this is also having the principal axis. So now we are keeping it F here. Now we are keeping we are taking F, and we are also taking center of curvature C. So now here we are keeping beyond C. Okay, it is not at infinity, it is very near to center of curvature. So beyond C, away from C. So here we kept the candle So we are trying to see here. So a ray, beam of ray that is traveling like this, parallel to the principal axis, and that is passing through the focus. Okay, so this is the first thing. So I'll just extend a little more. Second ray, so which is passing through the center of curvature now. Okay, so when it is passes through the center of curvature and comes back to the center of curvature again. So now where the image is formed, here is the image formed, right? See here, the object size is bigger compared to the image size which is formed. So now image details, we will write it as, so how is the image formed? The image is formed here in front of a mirror, which is a true image. So we'll say the image is a real image. Also it was inverted, right? So this is object is like this, but image formed is reverse. So this is inverted. So we'll also say whatever the image formed, that is smaller than the actual size. So it is actually diminished, and is also forming between F and C. So I'll write where it is forming between F and C. And also if you see here, it is smaller than the actual size, so it is also diminished. So now, so these are all the things for this one. Alright, so the second case. So let's see the third case. Third case, where it is forming at C, it is forming. So now this also we'll try to understand more clearly. So this is the third case, that is we are keeping at C. So now we'll take the ray diagram. Again the principal axis, again the same thing, center of curvature, also we are taking also focus. So now we are keeping the object on center, that is light on the center. So ray is coming like this, it is touching the mirror, and that is passing through the focus. Okay, so this is the incident ray and this is the reflected ray, right? So one thing we have to understand, so this is the object and this is the first portion. So the second ray which is passing, that is passes through the pole here, is touching the pole, and that is passing through again at the same position of center of curvature. See here, these both are forming at the same positions. So if you observe here, the sizes and everything is same here. So for the reason when we keep here, so here of course the image which is formed is actually that is real image, and also the image which is forming, first thing is it is real image, and next is it was inverted, right? So if you see the size, it is not diminished, even it was not enlarged, it was equal to the size of object, alright? So that is equal, and also it is forming where it is exactly forming at C. So that is real image, and also it is inverted image, and it is equal to the size of object, and it is forming at C, right? So here also if you take incidence, this is incident and this is reflected. So this is at C. I hope this is very clear. So let's see the next case. So next thing is this is forming between F and C. Okay, so we'll understand that also. So now between F and C, so it is taking a mirror. So we are also taking a principal axis, and in this one we are keeping a focus. We are also taking the center of curvature. Now as I already said, that is in between F and C. So now here this ray which is parallel, one ray it is parallelly going with the principal axis, and that is going through the focus, right? This is the first law. So where this is first rule. So this is incident and this is reflected. Okay, second one, if you just observe, the ray is passing through the focus, touching the mirror, and this is going parallel. So this is incident ray, this is reflected. So where it is forming C, it is forming over here. It is forming beyond C, right? Initially as we keep very far, the image is forming very near. Okay, as you move the candle forward, the image is moving away from the mirror. That we have to understand. Alright, so now we'll write the characteristics here. So the image which is formed is, it is a real image, right, and it is also inverted image, right, it is real, it is also inverted, and it is also what, bigger than the active side. This is very small, but here this is becoming bigger, so we will say this as enlarged. Okay, and where it was forming beyond C, beyond, okay, away from C, beyond it was formed. So this is the next case. So let's see the other one at F. So we have seen between F and C, now we were seeing at F, so we'll try to understand it more better ways. So now let's see this, that is at F. So when at F, if we see, so this is a mirror, concave mirror, coated at one side, and of course this is the principal axis. So now this is the center, and also focus is over here. So now here we are keeping the light source over here. Alright, so light which is coming, that is going like this parallel to principal axis, and that is passing through the focus. Okay, a second ray, it is going like this, touching the mirror, and it is coming back through the center of curvature. Right, so now let's see its characteristics here. So the characteristics, if we observe, which is kept at F, that is the image with whatever form, that is real image, it was also inverted, and it is also the image which is formed, this is coming over here, so as these both are parallel, these both are parallel and they are going away like this. So there is a thing which is saying in mathematics, where whenever the two parallel lines were there, as they move very far, like as it goes to infinity, and they will meet at infinity, so they are meeting at very large or very long distance. So then we can definitely say the image which is formed, it is very big, right? So they are meeting at infinity, which means the image formed here, so it is going very far at infinity, and at infinity they are meeting over here, right? So that we will say that they are meeting at infinity, so the image which is formed is enlarged. So where it is meeting? At infinity. Okay, so let's see the last case of concave mirror. So this is between F and P. So now here, if this is the, okay, let me take this little up, write this between F and P. So now I'll take a mirror. This is the principal axis, so center of curvature and also focus. So now we're just taking a light source here, and that is passing like this, touching the mirror. Okay, and as this is parallel, that should pass through what? That should pass through focus. So that is passing through focus. So next ray which is coming through this light source, that is touching the pole here, and that is going away like this. That is going away actually. So if that goes away from the center of curvature, what do we say? So they cannot meet any time, because they are coming, touching here, and that is going away. So this is in one direction, this is in other direction. They cannot meet any time. There is no possibility at all. If they are parallel, then at least they will meet at infinity, but one is going for other side and the other one is going to different side, so there is no possibility of them meeting. So for the reason, we will just extend these other side of the rays, we will extend them, both of them, and we will see where they are meeting. So they are meeting over here. See, this is imaginary, which is not actually true. So we are just extending on the other side of the mirror. So for the reason they are not real. Okay, so whatever the one which we are taking, this is called as virtual image. The real image is the real, actually which is possible, that is real image. The image which is not actually happening but we are imagining it, that is virtual. So now the image details if we take, so that is, so here also we have to write, this is incident ray, this is reflected ray, so this is again incident ray, this is a reflected ray. So image details, the image which is formed is virtual and it is also erect. We'll say this sort of ray as erect. Till now we have seen only inverted, like if the object is like this then image is like this. It was inverted image only till now we have seen, but now whatever the image we are seeing, that is straight. The image is also like this, even the object is also in the same way. So this is erect. So now whatever the image forms, see here object size is very small but the image size is very big, so for the reason this we will say as enlarged. So the image is enlarged. Okay, where it is formed? That is formed behind the mirror. Got it? So it's very simple to understand. I hope this is very clear. So this is all about concave mirror. I hope this is very clear to you, and in next video we are going to see the complete content about convex mirror and also its characteristics, and also we are going to see about magnification, and we are also going to do few of the problems regarding convex mirror, concave mirror, and also about magnification, where we are going to cover each and everything about reflection. By that you will get the full-fledged complete knowledge about reflection. So keep going, stay tuned.